Hello, welcome to this part where I shall be walking you through on how to use AstroimageJ to make your measurements. So this is the part where I showed you on how to download images from the LCO, how to download the processed images, the FITS files. So I will provide you a link on how to download, on the link you use to download the AstroimageJ as well as the uh, Java Java that will help you to run it in your Windows computer. So this is my downloaded images. Okay, so it is zipped. You can extract it, extract all. Okay, extract to just be extracted. Okay, let me just close here. So this is my extracted folder. So we open it, then we have another folder in there, then you open it again, then you have your 10 images. So we are going to be taking this to AstroimageJ for measurements. Let me go back. I will stop here. Then this is the AstroimageJ. Once you've downloaded it, this is how it's going to appear. It is not going to appear like an ordinary application like you have others, but like a folder. So you open the folder, then you have a couple of programs in it. You go to the application type, then you click it. AstroimageJ will open. So this is how it's going to open. Let me close this. Then you go back to your images. This is your images. You drag it in there and drop it. So brings you some things, count 10, start 1, starting from 1. So what to do is just click OK. And here it opens your images. So if you come over here, you will see your fit header. This is called the fit header. It contains information about the image. So for instance, this is the 1 over 10. I mean the first image out of the 10. If you want to see the other ones, you come over here. You can click. You see it's 2 over 10, 3 over 10, 4 over 10, 5 over 10, 6 over 10, 7 over 10, 8 over 10, 9 over 10, 10 over 10. So but we want to start from the first. So to start, you need to zoom in. You need to zoom into the image and also to locate your images. And to zoom in, these are the things you will need. You will need this one, zoom in fast if you want to zoom in fast. Okay. Then this one is, you want to continue zooming in. Then this is to zoom out. If you want to zoom out, this is zoom to fit screen. So it comes back to its original form. So now, if we zoom in very fast, you would notice that there are a lot of noise in this image. There's a lot of noise in this image. You can reduce that noise by coming over here. Then you can move it to your right. As you're doing that, you see that the 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 stars are becoming clearer and the noise is going out. Okay, so let me zoom out first. So look, let me look at this. If I want to zoom in on this part, I will just come over here, click there. Although nothing is going to, I will just click there and zoom in very fast, so it comes out. Okay, so now your image is clear. So depending on how much you want it to be, if you want it to be more clearer, you can adjust it to your taste. Let me push it back. Okay, now how do we know our target double stars? Okay, the next thing we're going to do is to locate our double stars. If you look at this whole image size, mostly your target image are usually at the center. So if you zoom in, if you click at the center, like I told you before, you zoom in really quick, you see the double stars. Let me do that again. So if I just click here, I'll zoom in quickly. I see that, okay? So this is my double star. But if you are in doubt, you can check the right ascension and declination. This is the right ascension declination. So if you bring your mouse, you'll see the reading there. So in right ascension is 716. So if you go back to the LCO, you can also see the right ascension that you entered, remember? So this is where we downloaded our images, this part, but to see the details, come over to the details, click here, then you come over to the right ascension declination. So this is 716. This one is minus 50, 59. So if you go back, you also see the same thing. So it means that they are the target, so that you don't spend your time studying the wrong stuff. So this is the target, and from here we can see it is a double star, okay, and they are well separated. So the next thing we're going to do is to, if you observe these apertures, there are three in number. We just want only one of them, and to make that possible, you come over here, you just click this, and you have only one aperture. It's important that we have this. So now let us make our measurements, and to make your measurements, let us zoom further. Let's zoom in more. Let me come over here, zoom in more. Okay, let me zoom out a little bit. Zoom out. Okay, zoom out. Okay, so now, and as you have zoomed in, your aperture has become bigger. So we want to take the measurement from here to here. Now, if you observe, if I point my mouse to this star, okay, I want to drag it. I want to hold down the left click mouse and drag it to this one, or maybe I can hold this one and drag it to this one. Any of that. Okay, but one is a primary star, the other one is a secondary star. I think this is the primary and this is the secondary. Because they almost look similar, but no problems. But the thing is, I want to activate the centroid of the mouse centroid, so that whenever I do that, it will pinpoint at the center of the pixel. So to do that, if yours is not activated, you can come over here and click on centroid aperture. So that whenever you click, it will be at the center of that star and not just any other place. Now, if I do that, let me take the measurement. You hold down the left mouse button. Okay, sorry, you hold down the right mouse button. Sorry, not the left mouse. Then, if you observe that the circles are overlapping, and if I leave it, nothing is going to happen. Okay, the reason is because the the circle, our aperture is enclosing the two stars. So we need to reduce the size so that it can only enclose one star. So let me close this, and if I want to wipe this so that I can do that again, I'll click on clear. So to set the aperture size, to reduce it, you come over to set. Okay, this is in 30,000. So maybe let me reduce it to 4,000 or 5,000 depending. Let me just make it 4,000, at least how it's going to look like. And whatever you, sorry, this is not 4,000, this is 4.000. Okay, so sorry for that. Then you click OK, and the size reduces. You see that? So whenever you take the measurement now, it will not give you that kind of error. So you come over here, then you drag it. There's no overlapping of the aperture, and you see the arc length. That's the separation, and the position angle is that. Then you leave it. The reading comes. So we want to take down this reading. You come over to your Word, insert table. I want to insert three columns. So this will be the position angle, and the separation. So this is this number. So for the first image, we got the position angle as the position angle is 269.61, 269.61, 269.61, and the separation is the arc length, which is 8.89. 8.89. Go over to here, 8.89. Then for the second image, let's move over to the second image. This is for, let me minimize this. This is for the first image. Then I'll do it for the second image. If I move this, it will bring me to the second image, but this is still there. I shouldn't use that, so I'll have to clear it so that I can perform for the second image. So I'll clear this and do the same. Remember, it is the right click button of the mouse. Then you have 269.47. 269.47. Where is my word? 269, 269.47, and the separation is 8.84, 8.84, 8.84. Then you do it for the third, you do it for the fourth, and that is how you do it up to the 10th image. Okay, so this is how you take your measurement of your position angle and the separation. After that, you can do your average and other calculations. Thank you.